Hello guys, in this video we are going to look at the method of cylindrical shells. Now, why do we need this method when we already have a disk and washer method? Well, here is the problem. Imagine that you are trying to rotate the following region. So this is given by y equals 5x minus x squared and the x-axis, but you are rotating it around the y-axis. Usually for a method that would give you something like that, which in this case would be a washer actually with respect to the y-axis, the difficulty would be to solve this for x as a function of y. It's not very clear how you can do that, okay? And especially for even more complicated cases where, imagine this was something like 5x squared minus x cubed. That's a cubic polynomial, right? And trying to solve that for x in terms of y is pretty difficult. Instead, what they're doing is they're doing a different type of slicing. And it's not a disk slicing, it's a cylinder slicing, but I'm going to explain it in a second. But first, let's just draw the region. So here we have 5x minus x squared. This is a horizontal, no, I'm sorry, this is a vertical parabola, 5x minus x squared, yeah. But it just looks downward. All right. Okay, so let's look at the parabola. So generally, when you have ax squared plus bx plus c, then the x coordinate of the vertex is given by negative b divided by 2a. Okay, so in my case, I have a equals negative 1, b equals 5, and there is no c, so c will be 0, which means in my case, the x-coordinate of the vertex is going to be minus 5 divided by 2 multiplied by negative 1, so it looks like that's going to be positive 5/2, right? So that's the x-coordinate of the vertex. And then to find the y-coordinate of the vertex, you need to plug that into the function, right, to get the y value. Okay, so I don't think it's going to be that hard, but I will use the Desmos calculator to do it. Okay, so we've got 5x minus x squared, and we want to know what it is at 5/2. Okay, so we got 25/4 here. 25/4. Okay, so let's see if we can graph it. All right, so excuse me. In order to graph it, you also need one more point. So, for example, when x equals 0, then y is also going to be 0. Okay, so we've got our 2 points. We've got 5/2. So let's select the parabola tool. We have 5/2, which is 2.5. And then what is 25/4? That's like, I think 6.25. Okay, so it's going to be 6.25. So somewhere here. Okay, and then 0, 0. And this graph does allow you to graph in 0.25 increments. So this looks like that would be 0.25, okay? So next, what we want to do is set it up to compute the volume, but we are using the method of shells. So what's going on with that method? Okay, so let me go ahead and take a screenshot so I can explain a little bit of what's happening. Let's take this region. And we are going to copy that here. And let me explain what's going on. Okay, so the region you are rotating, is going to be this one right here. So it's bounded by this 5x minus x squared and the x-axis, right? And again, normally what you do with respect to y, when you want to do the rotation with respect to y, if you're using the washer method, you need to know how to express x in terms of y. But you do not have to do that for shells. And again, rotation here is, even though the function is expressed as a function of x, the rotation is actually around the y-axis. So you're not rotating around the x-axis, you're actually rotating around the y-axis. So bounded by this and the x-axis, that's the yellow region. The x-axis is on the bottom, on the top you've got this region. So you're rotating it around the y-axis. But the way the slicing works, okay, it's not the same thing as that you used to. Instead of doing disks, which is like perpendicular to the axis of rotation, here you are actually doing parallel to the axis of rotation. So if your axis of rotation is the y-axis, you're going to be dividing it into these little subintervals this way. Okay, so just imagine that I'm dividing it into tiny little subintervals. And then when I start rotating these things, you're going to have like a cylinder inside the cylinder, okay? So you have this sort of what they call shell. So you've got one cylinder inside, okay? and then one cylinder just with the tiny little cylinder, one inside, one outside. Okay, something like this. Okay, something like that. And what can be shown is that this kind of shell. You just imagine a Coke, and inside it another little smaller can of Coke, right? So this is called a shell. So it can be shown, but that the volume of the shell is going to be 2 pi, and then this distance is actually, you can assume that that's x. Just think of like the distance from here to over here. That's like x, okay? And then you are multiplying it by the height, which is in this case f of x. And then you have to integrate that from 0 to whatever, well, from A to B. That's the formula for the volume using the shells. Now, why that's the case, I'm not going to prove it to you, but that's the formula, okay? So it allows you to compute the volume of rotation around the y-axis without explicitly solving for x in terms of y. Okay, so now that I told you that, let's go ahead and compute it. So we are going to start from 0 to 5, because that's how your x changes. Right here, 0, right here, 5, right? 0 to 5. Then we're going to have 2 pi x, and then our f of x was 5, what was it, 5x minus x squared? Yeah, so it was 5x minus x squared. Okay, now in order to integrate this, first of all, I'm going to pull out the 2 pi. And second, this x has to be distributed to each term, okay? So you're going to get 5x squared minus x cubed. Okay, so then let's see what happens. So this is going to be 5, and then x squared is going to be 1/3 x cubed, and then this one is going to be 1/4 x to the 4th. And now let's substitute 0 and 5. Okay, so let me at this point use the calculator. Where is my Dismas calculator? So let's define this function. This is a new function because this is antiderivative. We got 5/3 x cubed minus 1/4 x to the 4th. And we just want to plug in 4. I'm sorry, 5, not 4. Okay, and that's 625 divided by 12. And then we need to multiply that by 2 pi. So that is actually going to be 625 divided by 6 and multiply that by pi.